The wheel and axle is another example of a basic machine. We can make a wheel by cutting it out of cardboard paper. So just take a compass, make a circle, and then push a pencil through the center. So we now have a wheel and the axle. We can do a little bit of experimentation with that. Suppose I place my wheel on this pile of hooks. I can measure the distance that the axle rotates for one rotation of the axle and wheel. So here we go. So the axle, which is my pencil, rotates a total distance of 2.3 centimeters. Now, how about the wheel itself? Well, let's measure that. So we'll set the wheel along my ruler. We'll roll it. And it rolls 29.5 centimeters. So my axle rolled 2.3, my wheel 29.5 centimeters. And so you can see that for one revolution, the wheel moves a lot further than the axle. Another one that we can easily make is one in which I've taken just a plastic tube. This is a blood sample tube, and just glued it to a wheel. So here again, an example of a wheel and axle. I now place my axle through a clamp, but I don't make it tight. And then I take a nail and just punch a hole through here so that I can actually rotate this like a crank. So I still have a wheel and axle, but I'm modifying it now into a crank. And then we can attach a string to this. So we pass a string over the tubing, and you may want to put some glue on there if it's not overly tight, or some tape to hold it in place. And we now have a crank that can be used to lift. So again, we have a simple machine, a wheel and axle, in which case we're now using it to actually lift something. If we place a hook on the end, we can then attach a weight, attach it to that, and we can then crank it, and we should make sure that the string is fairly close to the clamp to support it. Of course, here we have the common device that's used for a well to lift a bucket of water out of a well. Another example of a very simple machine, a wheel and axle. And the mechanical advantage will again be the diameter, the ratio of the diameter of my turning circle, which is then from here to here. So that's the diameter of the circle through which I'm turning, and the diameter of the axle on which the string itself is being wound. I can of course also use this the other way. I'm going to support the free rotating end so that it stays in place. And if I now pull my string, I can actually get my wheel to turn quite rapidly. So in this case, I'm exerting the force on the axle, causing it to rotate, which in turn causes my wheel to rotate at the same number of revolutions per minute, but the distance through which the outside of my wheel travels is not much greater. And that's, of course, the principle of a bicycle wheel, where we exert a force with the chain on a sprocket. The sprocket itself is much smaller than the wheel, and so when we turn the pedals, we cause the sprockets to turn the wheel, and the bicycle then moves through a great distance for every revolution of the sprocket. Another variation of the wheel and axle is a crank. I've made this crank just out of a piece of wire and shaped it in this fashion. You really don't need a long piece, and you can have any dimension for this. So as I rotate the handle of my crank, it goes through a circle, so that's part of the wheel. And the fixed part here is then the axle. So a wheel and axle.